morning, students. Today we have another seminar class which is on covariant form of a Dirac equation, which will be presented by one of my students, A. Abhishek. And it's a long history. This equation, it was introduced by Paul Dirac, but we know that long history has been taken place right from 1905. So 1905, in the whole universe, it's a miracle year, because Albert Einstein introduced, he published 4 very good papers, the best papers. So one was on photoelectric effect. Of course, we know photoelectric effect very well. Then another one was on E equals mc squared. Then specialty of relativity, then Brownian motion. So all 4 papers in the same year he published. So that's why we think about this miracle year. And this photoelectric effect was later experimentally verified by Robert Millikan in the year 1960. Actually, he wanted to disprove the photoelectric effect equation, but at the end he proved it experimentally. So one paper had a full breakthrough. Then another one was about Brownian motion. Brownian motion is in which Albert Einstein introduced the behavior of atoms in the solution. So later in the year 1911, it was concept fully was brought out by Niels Bohr. Niels Bohr, in the atomic model, the electrons revolve around the orbit, and exactly it resembles exactly with the behavior of the atom, which was introduced by Albert Einstein in the year 1905. Then the third paper, E equals mc squared, it was proved later, 1930s, by Otto Meyer, who introduced the concept of the atom bomb. Then Oppenheimer, they also used the similar equation, E equal to mc squared. The last paper, which was on specialty of relativity, this is related to Dirac equation. This is what I want to discuss. So last paper, it was introduced by Albert Einstein. It was on specialty of relativity, and of course people did not accept earlier, but in the year 1919 it was experimentally proved by Eddington from UK. So at the time specialty of relativity came very famous, and also Einstein became very famous. So Einstein introduced 1905 in the year about specialty of relativity, but it was experimentally proved by Arthur Eddington in the year 1919. So people thought that every new theory should be interpreted in terms of specialty of relativity. So that's the idea. So after 1919, all the scientists, they decided that we must have all the theories, it should be interpreted in terms of specialty of relativity. So they started clubbing all the new physics in terms of specialty of relativity. So now in the year 1925, the special year for all quantum mechanics students, and Heisenberg introduced matrix mechanics. 1926, the very next year, Schrodinger introduced wave mechanics. And Schrodinger himself, he wanted to make his own equation in terms of relativity. That is, Schrodinger, he wanted to interpret specialty of relativity in his own equation, but he could not succeed. Of course, we know about the Schrodinger equation very well. This is second order differential equation in space, first order differential equation in time. So space and time do not match with each other. Of course, it's a linear equation, but he tried, but he could not succeed. Then there came in the year 1927 Paul Dirac. Paul Dirac introduced a new Hamiltonian beautifully and boldly, and this is about the first order differential equation both in space and time. That is very important. What we say this as covariant form of Dirac equation, and of course it is symmetric in both space and time, because this is first order space, first order in time. So Paul Dirac, of course, Klein-Gordon equation, we know Klein-Gordon equation, which also explained about relativistic quantum mechanics, but could not explain clearly about the probability, because they obtain only negative probability, which is not acceptable. And of course their equation, they don't have any symmetry, space and time. And of course, yeah, they introduced second order differential equation, both space and time, but they failed in terms of spin, fermions. So there's a discrepancy. So that's why Paul Dirac introduced this concept. He introduced the Hamiltonian, which is invariant form of Dirac equation, which my student is going to present today. Covariant means invariance in space and time, invariance in transformation of one system to another system under Lorentz transformation. So this is what the theory says. So with this introduction, I invite A. Abhisha to give a seminar class on covariant form of Dirac equation.
Good morning to all. I am here to present the seminar about the covariant form of Dirac equation. Myself Abhisha from PG final year in Government Arts College, Melur. Today we can discuss about the covariant form of Dirac equation. In according with the principle of relativity, physics must look the same in the all Lorentz frame. As usual, the physical law should be same in inertial frame. In this means the physical theory, their constitution with the principle of relativity must have the same form in all Lorentz frame. That is, they must be covariant. Covariant means invariant frame. We are going to examine the covariant of the Dirac equation. We are going to from one coordinated to another coordinated in symmetric in space and time. The physical law must be result is same. In this derivation, we mainly deal with the Dirac wave equation psi, which is understood to be the four component spinner. Let us see the component x mu. X mu is the r comma ict, where r is a xy is a space coordinated and ict is a time coordinate. Here is a four component, x1 is equal to x, x2 is equal to y, x3 is equal to z, x4 is equal to ict. We know that the Dirac Hamiltonian is linear in the momentum and the mass is given by. We know the invariant covariant of the linear equation H is equal to C alpha dot P plus beta m naught C square. Using the eigenvalue equation H psi is equal to E psi. Here E psi is equal to C alpha dot P plus beta m naught C square psi is equal to 0. Using the energy operator I H cross partial d psi by dt is equal to C alpha dot P plus beta m naught C square psi. Partial d by dt on the LH is not the Lorentz scalar because the time t replaces just one of the four vector. Therefore, thus x mu is equal to r comma ic. So it is not Lorentz covariant. The symmetric in both space and time. We now converted the covariant form in IH cross partial dou psi by dou t is equal to minus IH cross C alpha k partial dou psi by dou xk plus beta m naught C square psi. Here alpha is a Dirac spinner. What are the properties of alpha come and they will be alpha k is a space coordinated. K is equal to 1, 2, 3. Here 1 stands for x and 2 stands for y and 3 stands for z. Now we multiply the equation 4 by beta by c from the left. IH cross beta by c partial dou psi by dou t is equal to minus IH cross beta alpha k partial dou psi by dou xk plus beta m naught c square psi. Now we can divide it by IH cross. Here IH cross will be cancelled. I beta by c partial dou psi by dou t is equal to minus I beta alpha k partial dou psi by dou xk plus m naught c by h cross psi. Now we can multiply and divide it by I with the first term of the above the equation. Minus beta partial dou psi by dou ict is equal to minus I beta alpha xk partial dou psi by dou xk plus m naught c h cross psi. Introducing gamma term matrix, we can define it by gamma 4 is equal to beta is equal to 1 0 0 minus 1. We know beta is equal to identical matrix. Gamma k is equal to minus I beta alpha k is equal to minus 1 1 0 0 minus 1 0 alpha k 0. Now we can multiply this term. We will get 0 minus I alpha k 0. Here k is equal to 1 2 3 and mu is equal to 1 2 3 4. This is a space and time coordinate. We know that x mu is equal to x, y, z, I, c, t for 4 dimension coordinated. x4 is equal to I, c, t. So in equation 7, now will become minus gamma 4 partial d psi by dx4 is equal to gamma k partial d psi by dxk plus m naught c by h cross psi. Here multiply with the minute sign and bringing the RH terms to LH. We know gamma 4 is equal to partial d psi by dx4 plus gamma k partial d psi by dxk plus m naught c by h cross psi is equal to 0. Here gamma 4 stands for time matrix and gamma k stands for space coordinate. This can be written as gamma mu partial d psi by dx mu plus m naught c by h cross I is equal to 0. This is a covariant form of equation. Gamma mu is equal to x, y, z, ict. Gamma 4 partial d psi by dx4 plus gamma x, gamma y plus gamma x plus gamma y partial d psi by dy plus gamma z partial d psi by dz plus m naught c by h cross I is equal to 0. This is a covariant form of equation in Einstein conversion. In natural unit, c is equal to h cross is equal to 1. So here gamma mu is equal to partial dou by dou x mu plus m naught c by psi is equal to 0. This equation contains Lorentz invariant term and parties. Transformation time, reversal, charge contribution can be easily be found. Thank you.